So our arithmetic sequences, we're adding in between. When we're looking at our geometric sequences, that means we're going to multiply in between. So this would be our recursive definition where I can get like my next term. So this would be like our a sub 1 times r, whatever. Where r is our common ratio instead of common difference where we subtracted. Common ratio means I want to know the division, multiplicative. So if we have a common ratio where it's being multiplied between each piece, that's when we have our geometric sequence. And we're going to see a couple of these. I'm just going to give us our couple of pieces like our a7 plus 1, those kinds of guys that we're looking at. So when we have a geometric sequence, we can find our next term by multiplying by our common ratio. If we don't know our common ratio, but we're given two terms, we can divide them to figure out what is the common ratio. So our other formula we're going to need are kind of generic. I can use this to find any term in the sequence. I can find my nth term, my a sub n, if I know a sub k. And we're going to multiply it by our ratio with our n minus k. Again, we could use our a sub 1 with our n minus 1. Like, that's totally okay, too.
Can you go back one more?
Yep, I can go back for a second. And then on this one, this is our generic one. We had one with n's and k's last time. You can also do this just like we had where we have our a sub n. And instead of k being some generic piece, you could have our a sub 1 times our r to the n minus 1. So if you want to always start at the first term, you can do so. I'm going to make these a's be this kind of a just because otherwise they start looking awfully 90. So we're going to use these to try and find some terms in geometric sequences. So I'm going to give us a sequence, and we're going to find a couple more terms. So I'm giving us two sequences here. We've got 5, 15, 45 is how it starts. And it's glitching on me because it should have these guys. So if we have a sequence that's 5 and then 15 and then 45, what is happening between each of these pieces? It's multiplying by 3. So it's times 3 here, and then it's times 3. So that's the same thing as our common ratio, just like how it was plus 2, plus 2, plus 2 for our arithmetics. Our geometrics, it's what it's being multiplied by. I'm good at words. So our common ratio, what it's multiplying by, is that 3. You could also do that by finding the division of a2 over a1. 15 divided by 5 gives us that exact same thing. So if it's not something you spot, you can divide two neighboring terms. Bless you.
Thank you.
So if I have here my first term, I have my a1, I have my a2, I have my a3. We're asked to find our next 3 terms, so we want to find, bless you, a4. How am I going to find my a4? Multiply by 3. We're going to take our third term, 45. So our a sub k, our k is 3. And we can multiply it by our common ratio, 3. And that's going to give us our a sub k plus 1. So our next term. So what is 45 times 3?
135.
135. So our a sub 4 is 135. What about a sub 5?
420? Oh.
No. Come on, man.
Oh, sorry. Yeah. Okay, I was way off. 405.
405. I was gonna say, man, I've been in this business long enough to know, no, that ain't gonna happen. Come on. 135 we, times by 3.
Yeah.
Same thing, you know.
So we get 405. So what are we gonna get for our a sub 6?
A big number.
Really big number.
A big number. Luckily, calculators exist.
1,315.
1215.
Same
Yeah.
thing, you know.
Oh.
No, it's like the same thing. It's about the same thing.
It was our 405 times 3. Well,
I like
4
that.
times 3 gives us 12. 5 times 3 gives us 15. 12, 15.
That's a big number.
So could we figure out our generic, our a sub n? If I could figure out, because maybe I want to find out a sub 30, or a sub 50, or a sub 100. So our a sub n, our generic formula, I'll bring it in from the other page. That's when we have our a sub k times r to the n minus k.
It's R3.
R is 3. You can pick any of the terms we know to use as your a sub k. You could use the first, you could use the third, you could use the sixth. It genuinely does not matter.
Just do it to the one.
I was gonna say the first tends to be the smallest number usually, and so it winds up being like not awful. But we can get our a sub n if we take our a sub 1. Our a sub 1 is this guy up here, it's our 5. Times, we had that common ratio of 3. N is the piece we don't know, minus, and we used our a sub 1, so our k is 1. And we can leave it just like that.
Wait, what?
That's our generic.
Oh.
So we have our next 3 terms and our a sub n. We don't even have to simplify anything on it. And you can double check this. If I want to double check my a sub 4, 5 times 3 to the 4 minus 1, we should get exactly this answer. A sub 5, 5 times 3 to the 5 minus 1. Should work just fine and be exactly the same. So you can check that way. Questions on this one? Okay, let's look at B, same kind of vibe. We need to figure out how it's changing between the pieces. We need to find that common ratio. What are we gonna do?
1/2.
Yeah. So we can take our neighboring terms and we can divide them. So we can take our 4 over 8. And we can simplify that to be our 1/2. We can notice that these are dividing by 2, which is the same as multiplying by 1/2. However it is we notice it, we can figure out our common ratio is 1/2 here. So let's see if we can find our next couple of terms. We have our first term, we have our second term, we have our third term. Oop. How are we going to find our fourth term?
Divide 2 by 3.
So we're going to have our 2, which is our third term here, times that common ratio of 1/2, or divided by 2. What do we get?
1.
1. So what's our a sub 5?
0.5 or 1/2.
Yeah. We're taking our 1 times that common ratio of 1/2, and we get 1/2, or 0.5. I don't care if you do fractions or decimals. What about a sub 6? 1/4. So see if we can figure out what our a sub n is. How do we get our generic? There's several different ways to write it, but think it through for a second.
It's gonna be, because our R is 1/2, right?
Our R is 1/2.
So we can use a sub 1.
You can absolutely use a sub 1.
So it'll be 8 times 1/2 to the power of n minus 1.
N minus 1. And if you want to put parentheses around it, you can. Makes things clearer. You don't have to, as long as we're aware that that power is over the whole fraction, not just over our numerator. So that is 100% a valid way to write it. You could also do our 1 times 1/2 to the n minus 4, because that would be our 4, if you want to do that. Totally valid. But this works just fine. Okay, questions on this one? Let's look at one more. One more. So we're going to find the first 5 terms of the sequence. So we're going to do n1 through 5, or a sub 1 through a sub 5, and we're going to find our nth term. So they tell us that the first term is 3, and our common ratio is minus 1/2. So what's our a sub 1? Because we're after our first 3 terms. Is 3. They straight up tell us our first term is 3. We are asked to find the first 5 terms. So how are we going to get our a sub 2? Take our a sub 1, our 3, times our common ratio. Our negative 1/2. So that would give us negative 3/2, or negative 1.5. I don't care if you do fractions or decimals. So our a sub 3 is going to be what?
Negative 3/4.
3/4. Because we take our negative, I'll write it out, our negative 3/2 times negative 1/2. So we wind up with a positive 3/4. So how about a sub 4? Negative 3/8. A sub 5. 3/16. So let's find our a sub n, our generic. How could I find any number at all?
A sub n equals
3.
times negative 1/2 to the power of n minus 1.
N minus 1. Okay. So we're going to keep working with these tomorrow. We've got like 3 minutes to the bell, and I'm not going to rush us through another one. I mean, we could. I only have one other one in here. But I'm going to put this up here, because there's homework 3, which is the last homework in this chapter.
Is the last one?
In the chapter. 10-3 is the last section. We're going to work with our geometric sequences. Very similar to how we did our arithmetic sequences. What? For the final? We gotta get past the chapter test first. And then we have a little activity after that.
Little
We
activity?
have a little project. that we worked on.
Project? What project? I didn't get that.
There, the pocket up there.
What kind of grade would it be?
Project. It's gonna go into the quiz category.
So what kind of project are we talking about?
Oh, I'll